Klaus, Daniel, the last time we sat here was about a year ago. Since then, a lot has changed at Lilium and you have developed further. We will talk about that in a moment. But before we do, could you please introduce yourselves again? Let's start with you, Klaus.
Yes, Klaus Roewe, at Lilium since August 2022, so I will soon have my second anniversary. The 30 years before that, I've been at Airbus in many roles, almost always operational ones. The last one was, for 3 years, I was responsible for the entire service business unit with 8,000 employees worldwide. The decade before that, I did A320 neo development, production ramp-up, and series production. And before that, various other roles in the program, engineering, and production. And I'm happy to be here now working on revolutionary new technology.
Even after 2 years in the wild startup environment?
Yes, of course you see it differently than you initially imagined. There are things that go much easier than you thought, but there are also things that are much harder than you imagined. And you have to remain flexible in a startup anyway. And I think I have remained so, and that's why I'm happy every day to be here.
By the way, I'm really happy that you're on board. This is a role model that we need for the big German startups and grown-ups. That people like you, who have had a very strong career in a large corporate, dare to jump into such a startup again. Because that's, first of all, a risk, probably also a bit less salary, maybe more upside with participation, but it's a big leap. And with Daniel, who we will talk about in a moment, it is, of course, incredibly strong when you have such a very smart mind, but who simply cannot have 30 years of experience in the industry yet. That means, I think that's a very important model. So it's great that you have been on board for 2 years now, and I hope we see this in more startups, that when they experience successful growth, other experienced managers have the energy to say, I'm going to tackle this now.
Yes, especially since we have gotten along well for 2 years, and as you can see today, that will continue to go well.
I am as happy as Frank.
Daniel, what about you?
Yes, hello Frank. I am Daniel, one of the 4 founders of Lilium, aerospace engineer from TU Munich originally. We founded Lilium in 2015 as a group of 4. I was the CEO for the first 7 years, building the company up to around 900 employees. And since Klaus has been with us for 2 years, I have been responsible for research and development, so everything related to new technologies, new batteries, weight reduction, etc. But I am also active in fundraising and a bit of communication.
For me, you are basically the head, the inventor of the jet, of course, with your co-founders. But it's also impressive that you just came out of university and said, I have an idea, I actually want to change flying, and then you just started. At first, of course, very crazy, and today we are here, so really a great story. We'll link the whole thing again below. That means you can watch the first interview with both of you again. There we go into more detail about your resumes. Today, it has actually become a big industry. eVTOL, there are also, let's say, large organizations that see very large markets in it. We do too. There are fortunately even competitors from Germany, but of course also from the USA and China. Can you give us a bit of an idea of where Lilium stands in this eVTOL environment?
Yes, gladly. So basically, I would say we have the best aircraft, but there is no best aircraft. The question is, what business model are we addressing? What mission are we addressing with this aircraft? And for that, you can have the best product. And here, we differ greatly from actually all other electric aviation companies worldwide. There is this classic air taxi industry. This is also relatively often used in the media. We looked at it extensively at the beginning, in the first years, as you know, and it is basically characterized by having small aircraft with a maximum of 4 seats that fly about 10-20 miles over a city in an on-demand business model. So you are in the air for 5, a maximum of 10 minutes. We looked at that. There is a market for it, but it's not that big. And the problem we see with this market is that within Europe, in a city like Munich or Berlin, you can save relatively little time with it because you have to get into a car, into a plane, and then into a car again. What we do is different. We do regional aviation. That means we said if we fly intercity, then we can generate hours of time savings for our customers. And if we do that, it's okay for the customer to wait 15 minutes until the plane flies. That means you can pool passengers. The further you fly, the more people you can bring on board. And that's why we built a shuttle aircraft that can fly farther, that can also fly faster, where the technology is optimized for very efficient travel, but also very comfortable travel. And that's why we also chose the jet technology and not the propeller technology. So our aircraft will be optimally suited for this mission.
That is the big difference that you made from the engineering side, saying you have a jet and not an open rotor, so not an open propeller, which has always been discussed. But this is actually what allows you today to fly further and faster and gives you an unfair advantage.
Exactly, so you can't say the jet is right or the propeller is wrong or has pros and cons. It depends on the mission. That means the propeller is more efficient for takeoff and landing in hover, but propeller vertical takeoff and landing, VTOL aircraft, are less efficient in cruise flight. They have more vibrations, they are less comfortable. And the jet, in our case, requires more power, more energy for takeoff and landing, but is more efficient, more comfortable, a bit faster, and a bit safer in cruise flight. That means we have essentially brought the same advantages that you find in commercial jet airliners into this vertical takeoff segment. But it is not a kerosene-burning jet, rather it is a fully battery-powered aircraft.
So clearly a completely different concept here. Does this perhaps offer further possibilities for you in the future?
Yes, absolutely. It's always important to me. We are talking here, we throw everything into one pot and say these are all eVTOL. And that's true because they all fly electric and they can all do vertical takeoff and landing. But for us, or my personal focus is actually more on the E than on the VTOL, because the technology we develop is capable of being installed in larger aircraft. So I would say up to 100 seats, up to 2,000 kilometers. The only thing we need is better batteries, but you just have to wait for that. They are coming. Battery capacity is statistically improving 4.5% per year. And if you just extrapolate that, say to 2035, 2040, and then say now, of course, when we have these better batteries, we also need the corresponding propulsion technology, then I can build a larger aircraft with it. And jet technology has no limits. Rotor technology is always limited to these extremely short-range flyers because it is simply too inefficient in cruise flight. And if you want to fly efficiently, you fly at much greater height, and I can't get there with the rotor anymore. What we really want is to electrify aviation. And this is the entry-level product, which is an eVTOL, but it has the technological ingredients to fly electrically, conventionally in the future. And that is an important difference. We don't see ourselves as competing with these eVTOLs. We see ourselves competing with hydrogen aircraft, because the capabilities that this aircraft will have, the technology it will bring to a more conventional aircraft, are exactly those that a hydrogen aircraft aims for in terms of capacity or size of the aircraft, but also in terms of range, with the fundamental difference that this is much faster available, and in terms of energy conversion, it is 3 times more efficient than hydrogen. So I always prefer to talk about the E rather than the VTOL.
Okay, interesting perspective. That means this is the starting product, but actually with this jet engine, with all the technology that you have developed with the first model, with the first program, you have now created a platform on which you can build larger aircraft for longer distances as well.
Exactly. I think the eVTOLs as a whole will not decarbonize that much. They will simply open a new mode of transport that is per se decarbonized. But the effect on global warming is of course much greater if I can replace up to 80% of all kerosene-powered flights today with a battery electric flight. And that's what our goal at Lilium is. Our mission is actually decarbonization. And of course, we also want to create a new mode of transport that must also be completely decarbonized.
So in addition to the jet technology that enables exactly these aircraft, the battery is of course a very, very important component. And Daniel, where does Lilium stand technologically in terms of partners? How do you do it?
So the battery is the fundamental enabler of an electric aircraft. That's why we've put a lot of time and energy into it and are now at a point where we have stabilized the battery technology for market entry. That means we have now tested the technology for almost 4 years. We have then built corresponding partnerships, which have a production line here in Germany. This is Custom Cells in this case, which now delivers cells to us on a weekly basis. And the special thing about this production line is not only that it produces, but that it produces cells with traceability and quality management, which we need for aviation. And that means we now have the technology to, at market entry, when the aircraft is certified, in about 2 years, achieve 175 kilometers of operational range. That means the aircraft can actually fly further with reserves remaining when it lands after 175 kilometers.
for safety reasons?
Exactly, but the special thing about an electric aircraft, or specifically the way we are developing it, is that since battery technology continuously improves, we have designed the aircraft so that we can offer an upgrade to the existing flying fleet every 2 to 4 years, and that way every customer who already has an aircraft can benefit from the fact that the aircraft can fly further over its lifetime, and that is of course extremely interesting, for example, for leasing companies, where you normally have a business model where the aircraft loses 5% of its value as soon as it leaves the hangar. And in our case, it will first gain value until it actually reaches the end of its lifespan.
So today, normal aircraft have a relatively long lifespan. They sometimes fly for 20 or 25 years. That means you see this for the Lilium jets and the models that are yet to come. And you say the fuselage and everything and the engines are designed in such a way that we can replace the battery, and thus suddenly the aircraft can, in the best case, fly twice as far, depending on in how many years I replace the battery.
Exactly, and it will also fly operationally twice as far because the reserves always remain the same. And the energy you need for takeoff and landing is always the same. That means if we achieve only a 50% improvement in battery capacity, then I can almost fly twice as far. And we therefore assume that by around 2030, we can increase the operational range of the aircraft to roughly 300 kilometers, and it won't stop there. But we are not only looking into investing this technological improvement in range, but maybe sooner or later we also want to invest it in cost reduction or additional passenger seats. So there are currently about a ton of batteries in this aircraft. That means if I can remove 10% of it because the technology has improved, then I can take one more passenger and thereby also get closer to the goal of making this really a mass market mode of transportation.
And then there will also be software updates, which are probably better here than with a combustion engine. So through software updates and new batteries, the aircraft can be improved throughout its lifespan. And then it is, of course, a simple purchasing decision nowadays because I have bought something that actually increases in value.
Exactly. And to come back to what Klaus just said, he said that 2,000 kilometers can be flown with an electric airliner. Of course, I can't do that today. And I think the big difference, the way we think, is that we say an aircraft has to be developed 8 to 10 years until it is on the market. And then it is a program that is in operation for about 20 years. And that means I don't have to evaluate the aircraft based on today's batteries, but I have to evaluate it based on the batteries that I will have during the life of the program. And that's why if you go on the internet today, you will find scientists who say, yes, an electric aircraft can maybe fly 500 kilometers. And that's true. If I take today's electric car batteries, then that's roughly what I get. But it doesn't stop there because the physical limit, what chemistry can actually do, for example, a lithium fluoride battery could fly across the Atlantic. Maybe we'll never achieve that, I don't know. But what we can definitely see also in the roadmaps from our suppliers is that we will reach these 1,500 to 2,000 kilometers operationally.
That means the combustion engine is largely optimized, so to speak, in terms of what can be developed with turbines and so on. The batteries still have many opportunities. You don't know what will come, but there are many opportunities to achieve even greater leaps in energy density.
Exactly. Nowadays, almost 10 times as much research and development money goes into battery technology as it did 10 years ago. And accordingly, the curve of improvement, both in cost and performance, is actually higher now than it was 10 or 15 years ago.
You have already successfully introduced several aircraft into the market in your career. Where does the Lilium jet stand now?
Yes, we have. You might also hear it from the background noise. Like we have arrived in an industrial operation, and I am happy about the noise. Because where there is noise, parts are being moved and we are moving. This is our logistics center here. We're moving a lot of parts at the moment because we are currently building the second aircraft. The first aircraft is almost ready. It will not fly, but it could fly. We will use it as an integration test bench for our engineering. And the second one, which started 2 weeks ago, that will be the one that will fly first at the end of the year. And we will build several more this year. In total, almost 5 aircraft. So 3 flight test aircraft will be built this year. The last one will be almost finished, but the third aircraft, which is the second flying aircraft, will also be completed. And we are also building a structural test cell, which we need to do certain tests that we need for the permit to flight. This 5th aircraft will not be fully equipped. It actually only refers to the structure. But what I want to say is, when you reach the 5th aircraft, you are obviously not yet in serial production, but you already have a certain routine, and we notice that too. The first aircraft is kind of the pipe cleaner for many things, both for logistics and for our IT systems. How do I get it through the IT system? Because we want to build these aircraft according to POA, Production Organization Approval Guidelines.
That means you are building a basically final aircraft, just as the series production will run afterwards. It's not just somehow, but every process is documented and controlled, every part is defined and traceable, fully certifiable already.
Exactly, I wasn't there, but when you built the demonstrators, but I imagine it was more like a big party. Everyone comes with a part.
It wasn't a party. We were under the plane at midnight assembling it, but it was a cowboy operation.
That's what I mean, a bit of a Wild West manner. And we're not doing that anymore. We treat everything as flying material, and flying material has to go through all the processes that flying material has to go through. And so the first machine is already the most difficult because all the processes are applied properly for the first time. And we see now with the second one, it's already much, much easier. And in total, we will have built 7 aircraft. 1 stays on the ground, 6 go into the air, plus this test cell. And that will help us from now on to simply become faster with production.
And you are really planning to be in the air with the final aircraft this year, in a few months?
That's right. To achieve that, we obviously first need to finish the aircraft, but we also have to do a lot of tests, both on this aircraft and on the first aircraft, integration tests, but also component tests. If you look around, you will see that the buildings we occupy are currently filled with production activities, but also with test activities. For example, we now have 2 engine test stands over there. Historically, they were Alpha Jet engine test stands, which is very funny when you consider that a military engine used to run there, and today it's the smallest and most modern electric engine. We have to evaluate all these tests. We also have to do a lot of analysis. And when you integrate all this data, you can go to EASA and the Federal Aviation Office and say, now we want to fly. So there is still a lot of work for us to do on the physical side, building the aircraft, testing the aircraft, but also on the entire verification side. Verification means tests and analysis.
The goal is to be in the air with it this year?
Exactly. Before the end of the year, we want to fly with it, and that means with a pilot on board. So not remote controlled. Our 2 demonstrators have no pilot on board in Spain, but this aircraft is supposed to fly normally with a pilot on board.
Maybe, if I may jump in briefly, what Klaus just described is Lilium is now a proper aviation company. That's incredibly important to me. And we also differ significantly from many competitors or other companies in the market. Klaus is the visible spearhead of aviation experience, but beneath that are a few hundred employees who have brought in enormous knowledge and experience on how to produce such an aircraft to aviation standards. And that's why we received the Design Organization approval last year. That means we are certified by the European Aviation Safety Agency as an aviation design company. We have the personnel and processes to develop and certify a commercial aircraft to the appropriate standard, and we are now producing aircraft to the standard of an aviation production organization. And that's enormously important, to bring a commercial aircraft to market that meets the safety standards of other aircraft.
Prototyping is easy, production is hard, because it's about meeting these high standards. Yeah, really exciting months are ahead for Lilium, and it's nice to see that the second one is already under construction. What does that look like in practice after this first flight? How will you proceed until certification?
Until certification, the dominant aspect is the flight test program, of course. But that doesn't mean ground tests and analyses won't continue. They will. But the time-consuming aspect is actually given by the flight test program. We have planned an 18-month flight test program with 6 aircraft. You start slowly and carefully, and the first thing you do is identification, getting to know the aircraft, and then you open up the flight envelope. That means from very cautious flights, you move to high speed. You fly all possible maneuvers. You also fly beyond what you will later allow the aircraft to do. This is a full fly-by-wire aircraft, so with digital envelope protection, but you have to fly this envelope and beyond. And the authorities also expect that you demonstrate that you still have margins beyond what you allow the pilot to do later. So the first half of such a flight test program is typically identification and envelope opening. It's simply learning about the aircraft, further optimizing the aircraft in certain parameters. The second phase is typically planned for certification flights that you then conduct yourself. And at some point, the ESA pilots will also come on board and fly themselves. For example, they want to personally test the handling qualities and say, yes, this is safe enough for us. This is something a normal commercial pilot can handle. And the very last phase is essentially a huge amount of documentation. All this evidence must be properly documented. It must be analyzed, and then eventually the type certificate will be issued.
That means once you have the first flight, you can expect about 18 months where you conduct all these tests with 5 aircraft, up to the ESA pilots flying themselves.
Yes, 6. The one on the ground will also continue to do tests for learning, but also for certification tests. Certification tests will also be done in all the laboratories, especially for maturity tests, initial maintenance intervals, and so on. I have to repeat many tests several times to prove that I also have the maturity.
And then after these 18 months, you get the final certification, and then you can officially sell the aircraft.
I could sell it even without certification, but it wouldn't have any value. What's important is that the buyer can only operate it if the aircraft is certified. Otherwise, it can't be put into service. And of course, our customers must also have the corresponding preparations. That means they must also have the certification as an operator. They must also have trained personnel. And we are working on that now, that we have training facilities where pilots can be trained, maintenance crews must be trained. I need all of that from day one before I can go into service.
That's a very good plan and very exciting, but all of this, of course, costs a lot of money. What does the financing look like for this path until the aircraft will be delivered?
We have already raised about $1.5 billion on the open capital market, funds that mostly come from China and the USA. We also received venture capital from Germany in the last 2 rounds, the very last one just 2 weeks ago, which we are very, very happy about. But with this capital, we are not yet fully financed until the point when we become cash positive from the company's operations. So from building and selling aircraft, that means there is still a certain distance to cover until that happens. And there are various financing instruments for that. First, of course, continuing to operate on the capital market, which we do. But there are also other elements, and we are very advanced in terms of public funding. This ultimately doesn't mean that we accept gifts from the state or hope for welfare, not at all. It ultimately means that we get loans, not equity, but simply take on debt. And what the governments in Germany and France do is nothing more than securing these loans, which are normal loans at market conditions. Under European state aid law, it can't be any other way. I think our American competitors have other options, but we don't rely on that. In any case, securing loans through the public sector is a means for us to obtain debt capital. We have other possibilities. We now have an order book of over 700 aircraft. Many are MOUs, but also already 56 firm orders. Firm orders mean that we provide certain performance guarantees, for example, delivery guarantees, but also performance guarantees for the aircraft. And in return, we also receive down payments. And the topic of down payments will progressively play a larger role in financing the development and production expenses. So for the remaining distance until we become cash positive from operations, there are actually 3 elements: continuing to be active on the capital market, taking on debt secured by the government, but also using pre-delivery payments.
When you get the aircraft, it has a very, very high value. That's at least how I see it, because just the first aircraft alone is worth a lot in terms of PR. I mean, I like communication. If I imagine that cities, airlines, and whoever uses it, which is already of great value, opening up completely new transport routes and so on, and that's where people are going to say, I'm ready to make a down payment because such a Lilium jet has tremendous value for me. And that's what you're negotiating?
Absolutely. So the customers who make down payments do that to secure slots. And we know this from conventional aviation. There's been a shortage for almost decades. I just heard at the ILA, Airbus is sold out until 2031. And when our aircraft flies for the first time and when it enters service and the feedback from customers arrives, meaning both the airlines and the passengers who fly, I'm sure there will be a rush. And many anticipate this today.
And then I won't have a Lilium jet for 10 years.
And they say, I need to secure my slot now, otherwise I'll be at the back of the line and won't get my first Lilium jet before 2040. And the customers don't want that.
Especially with such a revolutionary product. Normally you have alternatives and similar things that are slightly better or worse. But a Lilium jet is really a revolution. Such a big leap that you say, whether I wait 3 years or 10 years makes a big difference in many ways.
So the customers who buy it have calculated a business case, of course. And they see that it will be a very profitable business for them, otherwise they wouldn't buy it. And it also has the side effect that it is very helpful for the ESG story. Aviation is somewhat disreputed. Aviation accounts for 2.5% of emissions, 8% in the USA. People say aviation doesn't really improve. They are just waiting for e-fuels and just want to keep making money. And here you can see that this is by far the most consistent and revolutionary approach to truly decarbonize. And it fits perfectly into the ESG story.
Now, of course, there is also competition. How do you currently see the situation?
Actually, there is no real competition. No, because we have so many unique selling points that in the rarest cases when we sell planes, we encounter competitors. So the classic scenario where 2 or 3 suppliers come and there is an RFP from the customer and you make an offer and then there are negotiations, that hardly ever happens to us. And there are several reasons for this. One simple reason is the entry barrier that US companies, for example, have in Europe because their development or certification standards are so low that they cannot even offer in Europe.
So, for example, Joby, which also has other issues like a smaller cabin and so on, they couldn't even say they expand to Europe. That doesn't work?
No, that doesn't work. We can, because we certify according to the highest standards. We can offer worldwide, but many cannot even offer in Europe or in countries that adopt the rules of the European Aviation Safety Agency. That's one thing. The other thing is, if we have to guarantee missions that have distances over 80 kilometers, naturally in all kinds of headwind conditions, they are all out. They all say we can also fly 150 kilometers, but not with 4 or 6 passengers on board and not with headwinds and so on. That means as soon as you start to slowly enter the regional market, we are without competition. There is none. Competition actually only takes place where it is really urban air mobility, where you fly very, very short distances, because everyone can do that. Of course, we can as well. And then there is again an exclusion in this market when it comes to serving the so-called premium market. That means serving customers who already fly helicopters or business jets today and who say we want to decarbonize, we want to eliminate noise, and that's why we want a Lilium jet. These customers have demands that only our Lilium jet can meet, because if you look at the cabin, it's a cabin like in a business jet. You have an incredible amount of space and it just looks cool, and it has the feeling of a business jet, but at the same time, an incredibly large economy. And what's very, very important in this segment is the safety factor. We certify to 10 to the power of 9, so the aircraft is as safe as an Airbus A350, and the US certified ones are significantly less safe, and the premium segment does not accept that at all. So, long story short, yes, in the urban air mobility VTOL segment, there is a bit of competition, but if we talk about premium, not at all, although that's a very small market. We believe in total it is 10 to 15%, and 85% is what we are doing here with regional air mobility. And then there are, of course, the certification barriers that many competitors cannot overcome at all.
That means actually there are 2 different aircraft, one for premium and one for airlines?
No, not at all. It is actually the same aircraft, but it can serve 2 different purposes, and the premium variant is just configured differently in the cabin. It has only 4 seats and maybe a few goodies on board. The shuttle or airline aircraft is a 6-seater where all 6 passengers face forward, but it has 20-inch wide seats. It has 34-inch seat pitch, which is significantly more than what you have today in the A320. So even this shuttle has a so-called premium economy comfort standard, but it is used in a very different way. A premium aircraft might fly 300 hours a year. A shuttle one might fly up to 2,000 hours a year. All our aircraft can do this, but what an aircraft needs to be able to do this at all is that it must be robust. It must have low maintenance requirements. Helicopters spend half their life in the workshop. This aircraft has almost nothing to maintain. The biggest maintenance effort is to occasionally change the batteries, and which takes about 4 hours. Other than that, I have a full carbon structure, which means there is no corrosion. I have electric motors that are indeed high technology, but very, very simple in terms of maintenance requirements. And I have a lot of electronics on the aircraft, which also do not require much maintenance. That was our approach. Make it so that you can use the aircraft very intensively for the shuttle market. The intensive use, the high transport capacity with 6 passengers, and the high range lead in turn to very low operating costs, and low operating costs in turn allow for very low ticket prices. And only through the low ticket prices will it actually be possible for many, many people to fly at all and to enter this shuttle business. And we are also totally unique in this respect, because our goal is, and we have also proven that we can do it, that flying 1 kilometer is not more expensive than driving 1 kilometer in a taxi. And what all our competitors, if they even like to talk about it, mostly they keep quiet about it. They are 4 or 5 times more expensive than us in operation.
So a real scaling story. Of course, you're also offering to the premium segment. Why wouldn't you? But the clear goal here is to have a lot of aircraft for many passengers with many flight hours to really transport a lot of people very efficiently from A to B.
There is a very broad consensus that by 2035, over 40,000 of these aircraft will be on the market. We personally believe that this is correct, probably even rather conservative, but we also believe that the majority of these over 40,000 aircraft will be primarily in this shuttle market. it can be assumed that Lilium is likely to achieve a very, very high market share. And we are also so sure that this will happen.
And this is not something where someone can just come around the corner and say, here is my new aircraft, but these are things that develop over many, many years. Just as you have developed the aircraft, that means you can already see today whether there will be a significant competitor in the next 4 or 5 years, because you would almost have to see them now. So that's how long it took to be at the point we are today. That is also the advantage for your company, that this is not as simple as in the software industry where someone can just pop up in half a year and say, nice idea you had there, I've just reprogrammed it. But you can't just build an aircraft out of thin air.
Exactly. So in the area of urban air mobility, short distance flying, yes, competition is foreseeable. Many are getting involved today, but not everyone will succeed. We have to be very clear about that. But anyone who would compete with us is not even on the horizon today. That means if someone were tempted to make the decision to enter this segment, we have to assume that we will be at least 5, if not longer, years in the market alone.
You have also built up a large team. How big is the team today?
We have about 1,050 employees at the moment, so we've grown significantly again, and that is also related to the production ramp-up. That requires more people.
That also takes time. Assembling such a team, bringing them together, you can't just do that as you often can with a software company where you can have very few people and a big product, but bringing together over 1,000 people was also a longer process.
Yes, we have always tried to grow very organically. We had 1 year where we almost doubled in size, but since then it has been relatively steady, and it can't really be any other way in aviation because we are almost always looking for very experienced specialists, whether it is in the final assembly of the aircraft or in engineering. And accordingly, it is actually more of a challenge to find the specialists and the personnel at all right now.
Awesome. Klaus, Daniel, thank you very much for having me here again. Wow, an incredible year and another incredible year ahead of you. Thank you again for being at the spearhead of innovation in Europe. I know it's not always easy. There is always some criticism, but it is minds like yours that push our country and Europe forward. And I believe the Lilium program can really be a beacon, or is already somewhat of a beacon. But now it is another very exciting phase to show that it wasn't just a great idea, but it is now a real company. It will truly deliver world-leading products, just like SAP or others from Germany have done. So a champion from Germany that can set international standards. This is exactly the point you are at now to show that. And I think it looks very good. I keep my fingers crossed and would say, see you soon. Thank you very much for having me.
Yes, thank you, Frank, for the interview. We hope to see you sooner than in a year, but we know, since we will have flown before, that you have certainly been here before.
That's right.
Thanks for coming, Frank.